see if we can make some sense of it. I will share my screen and we'll get started. So let's say I give you a function like f of x equals the square root of x plus 1 minus 3, and I tell you that x must be greater than or equal to -1.
Mhm.
So the first thing we're going to do is determine the domain. And I've actually already given it to you. So this has to be converted to set builder notation. So you've got x such that x is an element of the real numbers. This is always the case. And then you include this part right here on the right. The range is, I guess, a little more difficult. It comes down to this number here on the outside when you have a square root function. Because square root functions, they grow, they look like something like that. So this gives you the lowest value right there. So it's y such that y is an element of the real numbers. This is always in there. And then it's y greater than or equal to -3. But the reason it's greater than or equal to -3 is because it's opening up like this, or it's going up because there's a plus there in front that's not written. Is everything I've said so far review, like you feel pretty comfortable with that?
Yeah, just a little bit. It's still just so you got the range from the part where it says, like, in the equation it says -3, and that's where
Yes.
you're always gonna put it? Okay.
For the most part, yeah, but it depends on whether it goes up or if it goes down. Like if I have a negative out in front, this changes a little bit. And so we'll do an example like that, but
Okay.
yeah, hopefully like you see that it must go up and to the right here. Now it's not a vertex point, but this right here, if we loosely use the word vertex, and what we're really doing is we're talking about the transformations here. The starter point, what we're really referring to now as the starter point, is -1 comma -3. So for a just a regular square root function, the starter point is 0, 0. But here the starter point is -1 and then -3. And that's because when you subtract, when x is -1, or because it's +1, it moves left 1, and then -3 because it's going down 3. So the transformations here, if you will, and I guess your instructor likes to use these arrows. You're going left 1 and then down 3. And that's where this starter point comes from.
Okay.
So why does that matter? Well, let's graph the starter point. Here's the starter point, and we know it goes up and to the right somehow like that. But this also helps us with our domain. Do you see how there's nothing left of this point right here, this starter point?
Yeah.
And there's also nothing below this starter point. That's also how I came up with these values.
Okay.
Anything else on this you'd like me to clarify before we move on to kind of the next part of this, which is to find the inverse?
So what we've been doing in class is that we use the tables, but he doesn't want us to do that anymore. So basically what you have to do is find the domain and range, and then you use that to find your points, and then.
Well, I didn't graph this very well. Like this is not the correct, like exact points. Like to find other points, I almost have to make a table, but you're moving all the table points by the transformations, by going left 1 and down 3.
Okay.
So like the next point on a regular square root is at 1, 1. If you recall, like the square root of 1 is 1. You need to go left 1 and then down 3.
Okay.
And then the next like well-known point on a root function is 4, 2. Let me label these. I mean, you're still using a table, like he's saying the right things, but you still have to know the table, or you still have to either write it down or visualize it or somehow do it, because you can't do it without it. This point right here is moved left 1 and then down 3. And then we run out of room pretty quickly here. 5, 6, 7, 8, 9. 9, 3 is another one. It's going down 1, right, left 1, down 3. So this is the correct graph here of this.
Okay.
But I mean, like, even though I'm not supposed to use this, I mean, I have to. I don't know. I'm doing this even though I'm not writing it down. I'm still writing the points down, and you're just transforming them. Like each of these points moves left 1, and then each of these points moves down 3. Like I'm still doing it. I'm still doing a table, even though I'm not doing a table, so to speak. All right. So now, like I'm trying to find the 6 parts here. I think part 4 would be to determine the inverse function. So the original function was y equals square root x plus 1 minus 3. To determine the inverse, it's a recipe. You first switch x and y. So x equals the square root of y plus 1 minus 3. The second step here is to solve for y. So you're going to add 3 to both sides to do that. X plus 3 equals square root y plus 1. And then you square both sides to undo the square root. So you have x plus 3 squared equals y plus 1. And then last thing you do is you subtract 1 from both sides. So you get x plus 3 squared minus 1 equals y. You rewrite it y equals x plus 3 squared minus 1, where you just switch sides. And then the final step is you're really supposed to like be really correct here, is you're supposed to use this notation. F inverse of x equals x plus 3 squared minus 1. How comfortable are you with just what I just did?
It makes a lot of sense.
Okay. We're going to do a few of these today. I mean, I don't know how many in the time we have, but we could just work on some of these too if this was unclear. So then the next thing I want to show you here is the relationship between the domain and range.
Okay.
So we have domain and range, and we have the original function, and then we have your inverse function. Hopefully this has been shown in class. This is just review. But our original domain was x greater than or equal to -1, and our range was y greater than or equal to -3. That's from the original problem. And you, okay, and to be clear, you need to write it in this form up here, but we want to get the values here first. So there's a relationship, basically diagonally related. So the domain of the original function is the range of the inverse. But you can't use x down here, so you use y. So y must be greater than or equal to -1. And similarly, the range of f is the inverse, is the domain of the inverse. And these are the same diagonally here. But because the domain is x, not y, you write x greater than or equal to -3.
Okay.
And I really like this. Like sometimes I show it more generally, like whatever's up here goes down here, and whatever's over here goes over here. You have to remember this relationship, or you will confuse yourself.
Okay.
So is that okay?
Yeah.
All right. So the next thing is graphing, and like I'm gonna go to a tool here to make this easier to see, but then we can talk about how to do it by hand. So the inverse is x plus 3 squared minus 1. All right, so let me snip this in and then ask you some questions. Hopefully this is not the first time you're seeing this, so it's somewhat clear. So the red over here, this is your original function. This is your f of x, and your blue is your f inverse of x. And then this green line is the line y equals x. Do you remember why this line is drawn, the y equals x?
I don't.
So the idea is that this curve right here, it's a mirror because this curve is reflected over it. Okay. So more generally though, this point right here, which is -1 comma -3, it corresponds to this point right here, -3, -1. What do you notice about these 2 points? How would you describe them to someone not taking this class? Like, how would you describe what's happening without talking about inverses?
Um,
So
they're
let me jump in here. Do you see that they're the same numbers, they're just in a different order?
yeah.
Yeah, and you're going to see that again here. So see this point, this is 0, -2,
Mhm.
and that goes with this point, -2, 0. Now, do you see that there's like these are mirrored, like they're exactly the same distance from each other across this dotted line? Okay. Now you may be asking, well, what's going on here, Matthew, with this? Well, when I graph this, what I did not do is restrict the domain. So you got to be careful because this is actually not included, all of this here. Now, when I go and restrict the domain of the inverse function the way I'm supposed to, you will see that I get just the part that we want here. So let me show that here with a new snip. Okay. So do you see how more generally, like each of these known points are mirrored over this line?
Yeah.
And I didn't get the 4, but the 4 is somewhere here, and then it goes up there with that. So how do you do this if you don't have a really cool graphing tool like this? The answer is you go back to your table, which I know we said we're not supposed to do, but this is literally the only way to do it. You grab your table and you do just what I was doing, which is you switch the x and the y value. So -3, -1. So that point's -3, -1, -2, 0. You flip them, -1, 3, and then 0 and 8. And that's how you do it.
Okay.
This is the original. This is the inverse. Okay, so we can move on to another example, but that kind of is everything I would expect you to see. I stopped labeling the parts, but like maybe part 5 is the graph, and part 6 is the domain and range, something like that.
Okay.
Always wonder why instructors are cryptic, because you legitimately want to learn this, but it's like, well, what do I learn?
Yeah.
Can you give me just 30 seconds here? I'll be right back.
Yeah.
All right, I'm back. So Julia, let's do another one here. Would you like to do another square root starting problem, or do you want me to switch to a quadratic starting problem?
Can you do a quadratic, please?
Yes. So let's say f of x equals minus parentheses x minus 1 squared plus 3. Okay. And I have to tell you now, like it's not fair to like you have to be given what x can be greater than or less than in this problem. So give me just a moment here. I want to graph it first, make sure this is going to work out nicely. But the point is there, like, you need information. So x here has to be, I believe it's greater than or equal to 1. Yeah, so x has to be greater than or equal to 1. All right, and they're telling you that from the beginning. What in the square root problem, they don't have to actually tell you that. You can figure that out on your own. Like, you're supposed to know enough to be able to do that. And we can talk about that in the other problem. But for a quadratic, they definitely have to tell you that ahead of time. Okay, so first thing, and maybe we should do it this way. Like, we are going to do domain and range, but maybe we should figure out that, like, starter point or the vertex or like the transformations, because they're all kind of related here. So there are actually 3 transformations here. Can you name any of them for me?
So the last one is up 3.
Okay, it's up 3. Or I guess we can sure does like that. It's good.
Yeah. So there's a negative in front of the x minus 1. So that's a reflection. Wait, I'm getting confused. Wait,
It is a reflection over the x-axis.
Okay, yeah, that's what I thought. And then
So it's right 1.
Oh, okay.
And in truth, it actually corresponds with this point right there. And this corresponds to that right there also.
Oh, okay.
All right, so now that we have that down, the domain is given. The domain is x such that x is an element of the real numbers, comma, x is greater than or equal to 1. Is that okay? All right, now for a quadratic, it's kind of like a root function too. It either like goes up, or in this case, either opens up or it opens down. Does this one open up or down? And it's based on this out in front here.
Down.
Down. Okay, so this time it's going to be a y less than or equal to. And that number comes from this number here, just like it did in the previous problem. So say on the previous problem, it was -3. Oops, it was -3. But because it kind of went up into the right, well, here, went kind of up into the right. That's why we did greater than or equal to. Also because there was a plus in front. So they're all related. They all tell you the same thing. You got to kind of latch on to one of those things to remember. And I'll try to summarize it here after we do this problem. But this is y less than or equal to 3 because it's going to open down. Okay, so I mentioned that starter point. In this case, the starter point is the vertex because it's a quadratic. Can you tell me the starter point for this one? It's related to the domain and range.
Oh, okay. 1 and 1 and then 3.
Perfect. Okay. So let's make a really rough sketch here. Hopefully you get nice grids tomorrow to do this. So here's your starter point. And see, the thing is that what's kind of uncomfortable here is that it comes from 0, 0. And then I know you're not supposed to make a table, but you really do need to make a table when you do these. Do you remember the next point on a quadratic? On the starter, the basic parent function?
No.
So when x is 1, y is 1. Because 1 squared is 1. All right. And on the right here, we'll do the new ones. Okay. So that every time we have a point, we have to transform it. So the transformations are right 1, reflect over the x-axis, and then up 3. So the starter point, 0 is going right 1. So that becomes positive 1.
Mhm.
The y, you're reflecting it over the x-axis, which is staying there, and then you go up 3.
Okay.
So the next point right here, 1, 1, 1, which is normally here, we have to do the same set of transformations. Let me scroll up here so we can see them. The first one is you go right 1. So to go right 1, that becomes 2. This 1 becomes a 2 because you're going to the right.
Mhm.
This one right here, you reflect it over the x-axis. So instead of it being positive 1, it's negative 1. And then you add 3 to it.
2.
Yeah.
Okay.
Okay. And then the next point on the original function is like 2, 4, 3, 9. And we have to do the same thing. So the x variable, the value in the x column, that's easiest because you're just moving it right 1. You're just adding 1 to it. But the other point, you need to negate it, move it over this axis, and then add 3 to it. So it becomes negative 1 because 4 becomes negative 4, and then you add 3 to it, so it becomes negative 1. So that's down here. So hopefully you start seeing that looks like that. That's the graph there.
Mhm.
What about this do you feel like you couldn't do at this point? Or where give me some feedback, please.
It all makes sense so far, except for the table.
So how would you graph this? I guess is that's the question. If you had to graph it, which seems somewhat reasonable. Or how are you graphing it in class? I guess is a.
I mean, we were using the table. I kind of just don't understand how. So is the table on the left? It's the 1, 2, 3.
That's the parent function.
Okay, and
That's
so then you use the transformations from that equation
Yes.
to make your second one, and then you use the transformed points to make your graph.
Yes, exactly.
Oh, okay.
You said that perfect.
Okay.
Yeah. Well done. Well said. Yeah. So let's move on to finding the inverse of this thing.
Okay.
We'll come back to that graph in a moment. So the inverse, there's really another step in here, which is instead of f of x, you're supposed to write y. I'm not even sure I would consider it a step, but that's the first step, is to replace f of x with y. Then you switch x and y. So x equals minus y minus 1 squared plus 3. And then the goal here is to solve for y.
Mhm.
So you're going to subtract 3 from both sides. So you have x minus 3 equals negative y minus 1 squared. Now you have to undo this negative. So you're going to divide both sides by negative 1. And you're really dividing both of these by negative 1. Or you can multiply, like either way is fine, but it becomes 3 minus x. The negative 3 becomes positive, x becomes negative, and I just change the order slightly. To undo a square root, to undo a square, you square root both sides. Square root 3 minus x equals y minus 1. And then lastly, you add 1 to both sides. So this becomes y equals 1 plus square root 3 minus x, or you could write square root 3 minus x plus 1. Just make sure that that 1 is off to the side. And again, some instructors are really particular, like you must write f inverse of x, and you should do whatever they want because they're grading you. They're giving you the score for this. Okay. So from here, we can find the domain and range. Okay, that's generally the next thing. And I do think that this is super critical to do. Again, build this table. So we have your original function, you have your inverse function, and the wrong strategy is to try to like look at this new function and try to do it. You really want to go back to what we said originally. So originally we said that x could be greater than or equal to 1. And we said that y was less than or equal to 3. Do you remember that from earlier? That was from, it's way up here, but we covered that. Now, the relationship is diagonal here. So and sometimes like instructors say this, and I don't think this is very clear, but they're like, the range of f is the domain of the inverse, or the domain of the inverse is the range of f. And it's just, there's just too much going on. If you build this table, you see that, okay, like this must be in the top right. Okay, and then this must be down in the lower right, but you can't use x and y in the wrong place because domain is x and range is y. So there's your final answer for domain and range. Now, full disclosure, you're supposed to do the x such that x is an element of real numbers, x is greater than or equal to 3. And similarly down here. But it's more important that you recognize that these are the relationships between them. Any questions on that?
That makes sense.
Okay. I'm sorry, I have the wrong orientation. This is y less than or equal to, or x less than or equal to. It has to be the same direction, the inequality. And you're really supposed to put that back up here and say, okay, well, x must be less than or equal to 3 for this one. Okay, now to graph this, I'm scrolling back up. The reason I'm scrolling back up is like there's a lot of ways to graph inverses. Like some instructors like, yeah, graph this line and mirror everything over it. You said not to use tables, but really it's a table. You take these ordered pairs you just found and you flip them. So 3, 1, 2, 2, and minus 1, 3. You actually get some of the same points. Oh, I'm sorry, minus 1, 3 right there. And sorry, you get something that looks like that.
Okay.
Okay, so let me try to summarize some of the things that we've been doing here to maybe help. And then we'll do some more problems with the time remaining. So if f of x equals the square root of x minus h plus k, and these are numbers, like think of your example as x minus 2 plus negative 4, if you want. The domain is And I mean, there's a small variation on this because I guess I should ask you, have you seen any functions where it's the square root of like h minus x?
Yeah.
You have. Okay. So we should cover this. Okay. So the domain more generally is you set the inside part greater than or equal to 0. So like the inside part would be like x minus h greater than or equal to 0, or the h minus x greater than or equal to 0.
Mhm.
And then you just solve it. You just figure out like x is less than a number, x is bigger than a number, and so on. Is that okay? Like if you were to get a study sheet, this is what like you would want to try to remember is these things. And we'll try doing this with some subsequent problems. The range depends on whether the number outside the root, meaning like it's really, I guess I should point to, it's really like what's here, whether this is plus or minus, or whether this is plus or minus.
Mhm.
And I guess maybe it's the sign there. So if it's positive, the range is always y greater than or equal to k. If it's negative, it's y less than or equal to k. And you just strictly look at this thing on the outside here. Is that okay?
Yeah.
Okay. We'll do some examples, but now let me try to summarize the quadratic here. So if f of x equals x minus h squared plus k, and there could be a plus or a minus here, all right? They generally have to tell you what x is either greater than h, or they'll tell you that x is less than or equal to h. There's two possibilities when you have this. So that they have to give you that. So the domain is either x greater than or equal to h or x less than or equal to h, but it's given. It's always given. The range depends on whether it opens up or down. If it opens up or down. Okay. So if it opens down, well, actually up is more, that means it's a plus in front. Down is the minus in front. So it's referring back to that right there. If it opens up, it's always y greater than or equal to k. If it's opening down, it's y less than or equal to k. And you'll notice this is identical to the last one. It's completely identical to the last one.
Mhm.
Okay, the last thing I'll summarize here is that, and we've already done this a bunch of times, but the domain and the range, this table, here's your original function, here's your inverse function. Whatever goes here for the domain goes down here for the range.
Mhm.
Whatever goes here for the range goes up here for the domain.
Okay.
So let's do some more problems, but let's try to go back and say, okay, we'll go back to these relationships here. All right.
Okay.
Okay, so our next example, let's say it's y equals minus square root x plus 2 plus 5. Nah, that's too big because we won't be able to graph it. We'll just make it plus 1. Okay. The domain is not going to be given when this is your starter problem. It could be, but if you go back up to what I wrote in one of these places, it says to set the inside part greater than or equal to 0. So what that means here is you need to set x plus 2 greater than or equal to 0. And then you need to solve for x. So you just subtract 2 from both sides. So x is greater than or equal to -2. And that is your domain. So we would say x such that x is an element, real numbers, x greater than or equal to -2. The range depends on whether it opens up or down. Does this thing open up or down? And it's based on that right there. And then it's further based on this right here. The negative on the outside and the 1. So this opens, not opens, but it goes down because of that negative. So if you go back to our notes here, if there's a negative on the outside of the root, which is the case here, it's less than or equal to. So it's y element of the real numbers, y less than or equal to 1 because of that number there. What are and then there's 3 transformations. I guess we should get those now for this one. There's 3 transformations. Can you give them to me?
Okay. So it is one.
One, that's down here at the bottom. That's last.
And then there's a reflection with the x.
Okay, that's good.
And left 2.
Left 2, perfect. Okay, the reason we need those is we might make a table. We might want to, do the thing we're not supposed to do, which is to get some values here. So this is your parent function over here on the left. So we need to come up with the new set of table values to be able to graph this thing. So for the first point, you're going to move it left 2. So left only affects the x. That becomes -2. Is that all right?
Mhm.
Now this y point, we have to reflect it over the x-axis, which means negating it, and then move it up 1. So 0 doesn't reflect, but then going up 1 is +1. Now we have to do the same thing for these next couple of points here. So +1 on the x, if we're going to go left, that's -1. But then the y value, we reflect it over the x-axis, which it becomes -1. And then we add 1 to it, so that becomes 0. And we're reflecting that y value there. So 4, value of 4. So 4, you go left 2, that makes it +2. This 2 you negate, so it becomes -2 because you're reflecting over the x-axis. Then you go up 1, that's -1. And then the last point there is 7, and then -2. So if I make that graph here, whoa, that's bad. If I make a graph and I plot these points, -2, 1, -1, 0, 2, -1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. There could be some confusion about which direction to go. Like, is it to the left? Is it to the right? And there's no like general rules, but usually usually use, this is your starter point. You heard me use that phrase before. So it must be moving away from the starter point. Okay, so the next thing we're gonna do is to determine the inverse. So let me go back up and grab the parent function here. All right, so if y equals this, will you try to find the inverse function for me? Take about a minute and let me know if you have any questions and I'll work it out for you.
I think I disconnected there for a second.
Yeah, it's interesting. I'm seeing it here where it says you're still muted, but apparently you can hear me. Yeah, let me just work through this with the limited time we've got left, and just you can follow along if there's anything. So actually, I need to switch x and y first. X equals minus square root y plus 2 plus 1. Subtract 1 from both sides. You get x minus 1 equals, actually don't need those parentheses yet. X minus 1 equals minus square root y plus 2. Move the negative over. You're going to divide by -1. So you have 1 minus x. You can switch the order. You could also do it as minus x plus 1, but my preference is to do it this way. Both ways are fine. And then you square both sides here. So this becomes 1 minus x squared equals y plus 2. And then the last step is to subtract 2 from both sides. So that becomes 1 minus x squared minus 2 equals y. Y equals 1 minus x squared minus 2. And then that last step that I keep mentioning, like, is to replace y with f inverse of x. Now, if you got that, great. Let's talk about the domain and range. Let's make that table. Again, here's the original function. Here's the inverse function. Let me go back and look at the original function here. So the original function, the domain, we said was x greater than or equal to -2, and then y less than or equal to 1. What did I say there? -1, 1, +1. Okay, and then when you go diagonally here, you keep it so it's x less than or equal to 1. And then here it's going the other way, it'd be y greater than or equal to -2. This last line here, generally they want you to put the new domain in it, not the new domain, but the domain that goes along with the inverse function. And then lastly is the graphing step. And the graphing step, really it's easier to just go back to the table and to switch the points. One thing I did not do that probably is worth doing here is you definitely should probably say this is the original function and then show the inverse function. So if we just switch the points, 1, -2, 0, -1, -1, 2, -2, 7, probably be able to get this here. So 1, -2 is down here, 0, -1 is here, -1, 2 is here, and then -2, 7, 1, 2, 3, 4, 5, 6, 7. And it's supposed to have some curvature to it. And also because this is your starter point, you know which direction it goes. It doesn't go the other way. Maybe you can see it. I know it's all the same color here, but this line y equals x. Again, that's your mirror line or your reflection about this. So we probably don't have enough time to do any more problems, but is there anything about this you would like us to try to really quickly go over again? Anything for these types of problems?
Can you just briefly go over, so when you're going from the parent table to the transforms table, what's the like process that you go through to determine? So like I've kind of forgotten how you do that.
Okay, so we'll try to do it as quickly as we can here. But some of the things only affect x, and then some of the things only affect y.
Mhm.
So if it's like going up, I'm sorry, if it's going left 3, that means that all your x values go left 3. So that means -3, -2, -1, and 0. All of these numbers are going left 3. I'm subtracting 3. And then if I'm going up 2, I'm adding y. I'm adding that to each of these. So 2, 3, 6, and 11. Where it gets slightly more complicated, we did 3 examples of it, 2 examples at least of the reflections. Those would probably be good to look at again. So we do unfortunately have to stop here. I will send you the notes right away so you can look at it. And I appreciate you scheduling. I think you're really well prepared. Just if you've got time, give this another look.
Yes. Okay. Thank you so much.
You're welcome. Have a great night. Bye now.
Bye. You too.